These are the notes for section 4.2 part 1. It is on intersections, unions, and compound inequalities. We're only going to talk about mostly the intersections in these notes today. It's a very long section. We're going to split it up. So, and I will warn you, they're going to be kind of long. So the first thing I want to talk about is something called compound inequalities. So this is when you have two inequalities and they're going to be joined by one of two words. They can be joined by the word and, or they can be joined by the word or. So they can be joined by the words and or. We're mostly going to talk about the inequalities that are joined by the word and today. So when we talk about inequalities that are joined by the word and, that's called the intersection. So I'm going to go to the next page here if you need to pause. That's called an intersection. So an intersection is the set of all elements that are common to both A and B. The intersection is the set of all elements that are common to both A and B. So when we have two different inequalities, the intersection is when we're talking about only the numbers that are true in both of them. Now there's a certain way that we write this. There's a notation for it. So let's say we have an inequality. We're going to call it A. Maybe like x is less than 7. And when we have an inequality, we're going to call B. Maybe it's like x is greater than or equal to 1. If we're looking for the intersection of those, we put this symbol in between those two things. It's like an upside down U. That means intersection. I kind of remember it by, here's what I remember. An intersection uses the word and it has this symbol. And you can kind of remember that like it's kind of like an A. This symbol, you can put a little line, it's like an A. So intersection and use the upside down U. It kind of looks like an A. So when we're talking about an intersection, we're talking about if we drew it as a Venn diagram, if here was one inequality and here was another inequality, the intersection is what's true in both of them. That's the intersection of two inequalities. So we're going to do an example here where we're going to find the intersection of two sets. Pause if you need to. We're going to find the intersection of these two sets. I can't get that blue thing off, sorry. So we're going to find the intersection of the set 1, 2, 3, 4, 5, this set, and of this set. -2, -1, 0, 1, 2, 3. So what we're looking for is the numbers that are common to both of them. That's what intersection means. It has to be in one and it has to be in the other. So if I look at +1, I see a 1 in both of them. So 1's going to be part of my set. If I look at 2, that's in both of them. 2 is a part of my set. 3, that's in both of them. 4 is in one set but not the other, so that's not part of my intersection. Neither is 5. If I look at the remaining elements of the other set, -2 is not in both, -1 is not in both, and 0 is not in both. If it's not in both, it's not part of the intersection. So my intersection is just the numbers 1, 2, and 3. 1, 2, and 3. That's the intersection. I'm going to do one where you guys try to find the intersection of two sets. I want you guys to find the intersection of these two sets, just like we just did. All right, so this screen is not something you need to write. Okay, you don't have to write this down unless you want to. I just want you to know this. When we combine two or more sentences or inequalities by the word and to make a compound sentence, it's called a conjunction. So this is kind of like an intersection. Okay, a number is a solution only if it satisfies both inequalities. It only is a solution if it satisfies both inequalities. So for example, this is a conjunction. X has to be greater than -2, and x has to be less than 1. So we're looking for any numbers that are both greater than -2 and less than 1. That's a conjunction. You only have to write down this page if you wanted to. So we're going to do an example here. It says graph and write interval notation for this conjunction. X is greater than -2 and x has to be less than 1. When we graph these, I would highly recommend you get a highlighter. If you do not have a highlighter, I would maybe recommend going and trying to find one right now. So when I graph this, I want to make sure I go all the way from -2 up to 1 on my graph. Okay, I'm going to start at -3 to make sure I get a little extra room in there. Now here's what you're going to do to graph this. We're going to graph one at a time to start. Actually, I kind of lied. It would be really helpful if you have two highlighters, two different colors. Go get another one if you need to. So if I look at my first inequality here, -2 is less than x, or I can write this as x is greater than -2. I like it to be this way. The book always does it the other way though. So x is bigger than -2. I'm going to graph that with my first highlighting color. So I'm going to be using red or pink here. X is an open circle on -2, and it's greater than -2. So I'm going to highlight everything on the greater than -2 side. Well, pretend that looks nicer than it does. Okay, now you're going to use your other highlighting color to do the other inequality. So I'm going to use green for this one. X is less than 1. So I'm going to do an open circle on 1. And I'm going to use my other color to shade everything that is less than 1. So I'm going to go this direction now. The intersection is only what was highlighted in both of those things. So you can kind of see on mine, it's kind of black here where the colors mixed. Wherever your highlighters overlapped, because I want it to be true for both of those statements. And is the key word here. So when I graph this, you have to make a new graph now. We only want to graph the things that are highlighted by both of them. So if I see on my graph, the part that's highlighted in both is right here. It's an open circle on -2. An open circle on 1, and it's in between those two. So you can now just use one highlighter to highlight in between those two. That's the intersection. We also have to write this in interval notation. Remember, interval notation uses parentheses and brackets. My answer is everything starting at -2 but not including -2. So I use parentheses. And it goes up to 1 but does not include 1. So again, I use parentheses. So there's my graph and my solution in interval notation. I want you guys to try one of these. I want you guys to try graphing and writing this. X has to be greater than 1. So remember, you can also think of this as being this way. And x has to be less than or equal to 4. Has to satisfy both of those conditions. Anything that's greater than 1 and less than or equal to 4. All right, we're going to move on to some more complicated problems now. This is just another way of writing a conjunction or an intersection. Instead of using the word and, you can combine it and just use two inequality symbols. So this is saying that this quantity, 2x plus 5, it has to be bigger than or equal to negative 1, and it has to also be less than 13. It's kind of in between those numbers. It has to satisfy both of those. So here's how we solve this. Okay, the way I like to do it is to split it up. If you want to do it in one, you can. Actually, I'm going to split it up. So we're going to do, this is one of them, so I just wrote this out, just one inequality, and I'm going to write this side out as a separate inequality. So over here, I'm going to write 2x plus 5 is less than 13. So now let's go ahead and solve each of these individually. It's just like solving a normal equation. We can draw a line through our inequality symbol. On this one, we're going to subtract 5 from each side first. We're left with negative 6 is less than or equal to 2x. And then we can divide by 2. So we're left with x is greater than or equal to negative 3. I did not switch my sign because I divided by a positive 2. So here's one of my conditions. X has to be bigger than or equal to negative 3. But we had another set of conditions. We need to go through and solve that other inequality as well. So we're going to do the same thing here. Draw a line through my inequality symbol. Subtract 5 from each side. We're left with 2x is less than 8. We divide by 2, and we're left with x is less than 4. So now I have my two sets of conditions here. I know that x has to be bigger than or equal to negative 3, from that one in red, and I know that it has to be less than 4. So let's graph this. That really helps us see what our solution is here. It has to satisfy both of those conditions. So when I make a graph here, I'm going to use two different highlighters to start off. I'm going to go from negative 3. I'm going to kind of skip up to 4 here because I ran out of room. Go by 2s all of a sudden. I know that wasn't a very good thing to do, but as long as we can kind of see what it is for now. So I'll do my one in red here with the red highlighter. X has to be, we can also write this as x is greater than or equal to negative 3. So we want to close circle on the negative 3. And then we want to highlight or shade everything greater than it. For my other one, I'll use blue. X is less than 4. So I'm putting an open circle on the 4. I made it kind of big so I could see it over the highlighter. And I'm going to shade everything less than 4. So now we can see on mine where that the kind of weird highlighting color is. It's this area right here is the intersection, because we only want what's true in both of those inequalities. So I'm going to redo my graph because you can never leave your graph with two different colors for a solution. We need to make it nice and neat so I can really see just what the answer is. Our answer is only the range from negative 3. I guess I'll go, I'm just going to, honestly, if you skip some numbers, if I can just see where your numbers are in relation to each other, I'm okay with that for now because I know you guys know how to count on your number line. We want our closed circle on 3. We want our open circle on 4, just like we had before. And we're only going to highlight everything that was in between and fell in both of those conditions. So that's our graph solution. If we wanted to write that in interval notation, we range from negative 3 to 4. X could be equal to negative 3, so we want a bracket. It cannot be equal to 4, so we want a parentheses. And that's our solution. So I want you guys to try one of these. So here's your problem. Try it very similar to the last one. I just have two more problems for you. Sometimes weird things happen. So I'm going to show you 2 times something weird happens. Alright, so on this one, we know that 2x minus 5 has to be greater than or equal to 3. And 5x plus 2 has to be greater than or equal to 17. Both of those conditions have to be true for x. So let's try solving each of these. I'm going to do this one first. 2x minus 5 is greater than or equal to negative 3. We'll solve this as usual. So we're going to add 5 to each side because we have to undo adding and subtracting first. We're left with 2x is greater than or equal to 2 because negative 3 plus 5 is 2. Then we can just divide by 2. So we're left with x is greater than or equal to 1. That is one of our sets of conditions. X has to be bigger than or equal to 1, greater than or equal to 1. I'll do my other one over here. 5x plus 2 is greater than or equal to 17. Again, we'll solve as usual. We'll subtract 2 from each side. We're left with 5x is greater than or equal to 15. And then we can divide by 5 on each side to have x is greater than or equal to 3. Those are my two sets of conditions I have to satisfy. X has to be greater than or equal to 1, and it has to be greater than or equal to 3. You might already notice what kind of weird thing is going on right here. If I graph both of those right now, x is greater than or equal to 1 and greater than or equal to 3, let's try the first one. X can be 1, it says, and it can be greater than 1. So I just graphed my first one there. I just graphed this one. X is greater than or equal to 1. Now I'm going to graph my second one. I'll do this one in red. X is greater than or equal to 3. So close circle on 3. X has to be greater than or equal to 3. So I'm going to highlight my greater than side. Now you can see mine changed colors here. The part overlapped in both is only on one side of those. That's because if we say x has to satisfy both of these conditions, we're saying it has to be bigger than 1 and has to be bigger than 3. Well, if it's bigger than 3, it's already bigger than 1. So really, we can just say this one. If we just say x is greater than or equal to 3, we've satisfied both of them. Because if it's bigger than 3, it's definitely bigger than 1 already. So if we're going to graph this, we really just graph that one inequality. We really just start at 3 and shade everything greater than 3. If we were going to write this in interval notation, we go from 3 all the way up to infinity. X can be 3, so we put a bracket on it. It can't hit infinity because infinity's, you can't really hit infinity. It's not just one number, it's an idea of the biggest number we could have. And that's our solution. So sometimes they overlap. If it's an intersection and you only want to pick the part that's true in both of them. All right, one more. I know these are long. I'm sorry. This is the last thing. Here's another weird one. Okay, so we've got two problems here. I'm going to solve these as usual. So my first one, I'm going to add 3 to each side. I'm left with 2x is greater than 4. We can divide by 2 on each side, and we're left with x is greater than 2. There's one of my sets of conditions. X has to be bigger than 2. Let's find out what else has to be true about x. So my other one, I'm going to draw a line through my inequality symbol. I'm going to add 1 to each side. So 3x is less than 3. And then we divide by 3. So I'm saying x is less than 1. So here's what this problem is saying. X has to be greater than 2, and x has to be less than 1. You know what I'm just realizing, guys? I forgot in the last few problems. We should have put the word and here for our solution. Sorry about that. For our solution, since it started with the word and, you want to put the word and in your solution. Okay? So with this one, you want to put the word and in between these two. Sorry about that. We can talk about that in class if it's confusing. So on this one, we're saying x is greater than 2 and x has to be less than 1. Has to be both of those things. You might already be thinking something weird is going on here. If we try and graph that, let's graph the first one in red. X is greater than 2. So x starts at 2. It can be anything greater. Now we're also saying that x has to be less than 1. That way. There's nothing overlap. That's because there's nothing that's bigger than 2 and less than 1. That's impossible. So our solution here, when we're really writing our solution, is just this. Empty set. No solution. There's no x that satisfies both of those. We're going to move on to something called unions in our next section. This is already pretty long. Again, sorry about that. But this is the end of 4.2, part 1.